Welcome to Spring Lib.
Okay, so they want us to draw what is actually N4O is nitrosyl azide. And the structure is N, 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 O. Okay, so there's the skeletal structure. You pretty much need to know that to be able to start the problem. So it's not the best question in the world. But either way, from here, we still have to assign charges and lone pairs and extra bonds and all that good stuff. So recall that nitrogen is in group 5. So if we have 4 of them, we get 20 electrons. And oxygen is in group 6. So we get 6 electrons. So altogether, we're going to have 26 electrons total. We've used 2, 4, 6, 8 of them. Right? So we have 16 more electrons to distribute. Okay. Now we want to minimize formal charge. So one idea that we might start with is to give oxygen 2 lone pairs and 2 bonds, because oxygen with 2 lone pairs and 2 bonds is neutral, right? So it might be wise, if possible, to have neutral oxygen. Just a thought. Okay. So we've used an additional 2, 4, 6 electrons. So we have 10 electrons left. All right. We are going to want to give everything a full octet if possible. So let's try to give this nitrogen a full octet. Okay, now we've got 8 electrons left. What about this nitrogen? Now, we can't really give nitrogen, if we have a nitrogen with 2 lone pairs and 2 bonds, it's going to be 2 minus, right? Or wait, let's see, it's going to be 1, 2, 3, 4, 5, 6. It's going to be, I guess it'll be just 1 minus. So that's okay. All right, so maybe we could try that. Let's put a lone pair here, a lone pair here, a lone pair here, and a lone pair here. All right, that leaves us with 4 electrons. We could try to do more. Put a couple lone pairs here and a couple lone pairs here. Okay, but now we'd be out of electrons, right? And we'd have a double negative charge, which we know isn't the case, right? We should have a overall neutral molecule, an N4O. So maybe our first thought might be to erase these double bonds, erase those lone pairs and make a double bond there. And then we still have 2 electrons left. Okay. And now we've got 2 electrons remaining. What if we put a bond here? Okay, all of a sudden this would have violated the octet rule, so that's no good. So let's remove those electrons, and we still have 2 electrons left. Okay. So how are we doing so far? We've got 2 electrons left to apply. Sorry, 4 electrons left at this point. Okay. This now has a positive charge since it's nitrogen with 4 bonds. What if we put a lone pair here and a lone pair here? Then we'd be back down to 0 electrons, and this would have a negative charge. If you ask me, this is probably the best we can do, right? It's overall neutral. We've got 2 charges, but really there's no way we can reduce that. So this is the structure that we want.